Hello, 5.2 or 5.1 part 2 video. I'm going to review just the ending part of part 1 video about the end behavior because if you were in class, this is what I would do and I want you to visually see what's going on. So for this first problem, I want you to tell me the end behavior. This is already in standard form. Now, when you're looking at this, the first thing you want to look at is the degree. The degree is 4. That's even. So in your head, you should be thinking like this, even. Even's always in the same direction. Even, same direction. So when I look at my leading coefficient, this is backwards. It's positive. So if it's even, same direction pointing up, positive means that's going to be stays the same. So that would be up. My end behavior would be up, like this always. So the second one, this is a not standard form. Notice how the highest degree is not first. However, at the same time, I can still look at what my highest degree is. It's going to be x cubed. Now, for x cubed, it would be down, up, down, up, down, up, down, up, down, up. So it's opposite. When it's an odd degree, it's opposite. Now, because of this subtraction right in front of here, the opposite means that it flips the arrows. So odd is down, up, flips the arrows. So that means my end behavior is going to be up, down, up, down. This is kind of reversed, so I don't know if it's like looking in a mirror. And then lastly, my leading coefficient is, or my degree is a 2, so that means it's even, so it's going to point in the same direction. And then since it's positive, it's going to stay as up, up. So that was just a little review. Now, we're going to get into the actual part 2 part of the 5.1. So we actually have to talk about graphing. So when we have these different degrees, the graphs will look a lot different. So if you have a degree of 1 that's linear, that's like basically all of all of the algebra, that whenever you took algebra, is degree of 1 linear. Degree of 2 is called quadratics. We're going to be getting into a lot of quadratics. So degree 2 quadratics. Cubic is degree 3. So it has this little whoosh when it's degree 3. That is a lot more focused on in pre-calc. And then we have degree that would be higher. Both of these technically are degree of 3s. Depending if you have a curve, will be if there's a lot in the equation in between. So graphing. So when I'm going to be graphing this, like so, you use your graphing calculator, you want to find a table. So first I'm going to look at this right here, and I'm going to plug this into my equation. It's sometimes hard to do it on here. I'm going to go to my y equals right here, and I'm going to type in the 0.5 because that's 1/2. Here's my x. This is the button you use for your x, and then this is your raised to button, if you can see that, to the third. And that's my only equation, so that's how I type it in. I'm going to go to my table. So look how the table says it's light blue. That means I have to push second first, and then this graph button to get to my table. When you're in your table, it's nice because it gives you numbers to have to graph with. Now, I'm going to write down numbers from my table on my piece of paper here. That will be easy to graph. So I'm going to write down -2, -4. For a cubic, you should have 5 points. -1, -1/2. We have 0, 0, 1, 1/2, and then 2, 4. And then remember, this is your x value. So -2, -4, -1, 1/2, 0, 0, 1, 1/2, and 2, 4. Now, when you're doing cubic, it should kind of give you a whoosh, like there should be a curve right here. And that's all you have to do for that problem. Graphing, using your graphing calculator to get to the table. Now, if I push graph, it will show up here to make sure that my graph is essentially correct. If for some reason you were like zoomed out really far, you would want to go to window. If it didn't look like this, you would want to go to window, zoom, go to zoom, push zoom, and standard. Zoom standard is always going to give you a 10 by 10 grid. So those are typically the graphs that we have. So if you want to try to pause the video and work your calculator to see if you can get this correctly, I would do that now. So when I'm typing this in, since I didn't ask it for it to be in standard form, I don't have to change it. so I can type it exactly how it shows on my paper. I'm going to go to my table. Now again, if you notice for a cubic, there's usually going to be kind of like numbers that repeat. It goes smaller, smaller. Oh, there's probably the term. I'm going to have -2, 2, -1, -2, 0, 0, 1, 2, 2, -2. Now let's see here. -2, 2. -1, -2. 0, 0, 1, 2, and 2, -2. Now, if you're like, what am I supposed to connect my dots there? Well, if you push the graph button, it will kind of show you what it should look like. So it should have, and then it goes up, it turns around, and goes down again. Now, if I were to write this in standard form, I should be able to tell what my end behavior is. So it's odd, so odd typically goes down, up, like so, but this is negative, so it would flip it, so it would go up, down. So if I didn't have that graph button there, I would know, oh, I had to start my pen at the top, because I had to start up, and I have to go through each point up, then I turned, and then I turn again, and I go down. But graph and calculators are pretty nice. And then the last part is you have to be able to look at a graph and determine, is it odd and even or is it positive, negative? So two different things. So first thing when you're looking at graphs, you want to look at where do the arrows point? Do arrows point? So either in the same direction or different. So these are the questions that you ask yourself. The second question you want to look is, did it flip? So looking at this first one, these are going in the same direction. They're both pointing down, so that's going to tell me that that's even. So this would be even. Remember, typically even points up, up. These are pointing down, down. That means there's a negative there. If it flipped, that means it's negative. So this answer would be even, negative. Here, my first question is, where do the arrows point? They are pointing in opposite directions. Opposite directions means it's going to be odd. Oddball. So normally for odd, it's down, up. Okay, so my arrows are starting down and then it finishes up. That's my end behavior. So that means it did not flip. So my leading coefficient is positive. Positives. I don't know why I put an S there. Where do the arrows point? Both of them are pointing up. That's the same direction. So it's even. And it did not flip because they're both pointing up. So it's going to be positive. And that is all I have for you for the 5.1 part 2 video. So have a great, grand, wonderful day and an even better tomorrow.